this this platform. So let's see. This might be the most awkward first chat. And all right, it looks like we've been live. All right, so folks, welcome to the first casual causal chat. This is an outgrowth from the book club that we've been doing every couple of weeks, where usually I talk to you. Interesting sort of technical backstory on this. Typically, when I talk to you folks, I'm using OBS Studio, and there's one setup to get it to work that way. But this is the first time we've had a guest, as you can see here, with Demetri. So I've had to switch to this new platform called Restream.io. Hopefully, it's working out for you, because this is literally the first time I'm using it. Hence the a little bit of an awkward intro. So if you're on the chat, I would actually appreciate it if you sent a message. That way we know that you're here. I can see that there's supposed to be 4 viewers. But if not, it'll just be Demetri and I chatting for a moment here. Well, at least a little bit more than a moment. So that's all. Demetri, extended chat. Yeah, extended chat where people get to view it later on YouTube forever. So this is recorded. Remember, this won't disappear like all the Zoom calls that we're used to. So don't say anything too embarrassing.
Okay, I'll try.
Well, I had an intro for you, and you haven't heard it. So you want me to give you your intro first, or do you want to take your own intro?
No, I'm interested to hear how you would introduce me on a platform which will be recorded and disseminated widely. Go for it.
All right. So I am thrilled to have Demetri as the first guest for a couple of reasons. We'll start with the technical ones, and we'll move to the social ones. But from the technical ones, Demetri is one of the most practical and pragmatic statisticians that I know. And I've met Demetri through Google Summer of Code. And it feels like ancient history now, but it wasn't too long ago. But I really love the way that he dug into the code. He worked on his project for ordinary differential equations. And he really just dived in. And then I just started seeing all of the sort of, I think you're going to disagree with me, but I think this is true. All of the knowledge that was in Demetri's brain. So he's got a lot of great statistics knowledge. He knows a lot about domain expertise. And the way that Demetri was able to blend the two together. And so I've linked one of his tweets in the description. You guys can look at it below. But these sort of mixing real life. I'm gonna go get a beer on a Saturday, and I'm gonna think about causal inference, just the right amount of vibe that we want for this sort of chat. And then the other is, again, this being the first test one I do. If things got a little messed up and the stream fell and this and that, Demetri would be really cool about it. So. Great guy to chat with, great guy to talk to, and he's been really diving into causal inference. So I think, Demetri, you recently bought the effect. You've been thinking about these topics more and more. You're not a causal inference trained person from academia. You're getting into it like the rest of us. So again, same level right now as the folks in this book club. We're all in it together, trying to learn this new topic. We're all learning one chapter at a time from textbooks on our own. So that's my intro and why I thought you should be here as the first guest. How do you feel? Do you want to add anything to that intro? Is it sufficient? What are your thoughts?
I think that was great. I think that's exactly what I would have said. We met during Google Summer of Code. I bought both the effect and the mixtape, and I've been learning. I have been going out for beers and reading it. It's kind of interesting because for the first time, like normally people have been like, "Oh, Demetri, like tell me about stats. How do I learn stats? Or do you have any book recommendations?" And I always have to say no. I don't have any good recommendations for stats. But to find myself on the other side of that table now, to be like, I'm trying to learn this on my own. Does anybody have any recommendations? Is sort of funny now. So I'm happy to be with all of you, learning and frankly struggling together. So
well, it's good enough. You got a fair amount of PhD training in your belt, great amount of stats, and you're struggling as well. So we've got folks. I don't know if you can see the chat. I can see that. People can see us. They're actually listening in. So there's a sizable audience here. We got some of the regulars like Ambika, Luke, Annie, and Julio, and apparently another fellow compatriot from Greek, Alexandros. So
Yesus, picante.
There we go.
There you go. Yeah.
So in these casual chats, I also admittedly am winging a template. I was going to just ask you just questions both about why you decided to learn this, what topics you're finding interesting, what you're going to learn next, what kind of approach you're taking, and make this about 20 or 30 minutes. That sound good to you?
Yeah, I mean, well, yeah, that does sound good, but I don't want to be the focus here. I mean, I admittedly I
Yeah.
haven't been keeping up with the book club, so why don't we start answering some of these for you? What got? I mean, it's one thing to sort of like read these books, as a lot of people are, but well, what prompted you to start learning about causal inference and make a stream of it?
Yeah, so this so gonna probably I mean I'll dive back farther into my history than I like, but there was a time where I was young and in college in a bachelor's degree, and I was doing a mechanical engineering degree, and I really liked mechanical engineering because you could see you could see a plane, right? And you're like, what makes a plane fly? And you could describe it with equations because it's all based in physics, or you could say what makes metal melt, and you could describe that with chemical bonds, or you could say what makes a control system work. And because they're all physical systems, like there is a fundamental truth to how they work that's unalienable, and like it's just a part of the world. And so, in a sense, I could use math to describe a cause, right? It's like we fly a wing of this shape at a certain rate, and this happens. And there's Bernoulli's principle, not the statistics Bernoulli, because these early statisticians they did way too much stuff and they are geniuses. But there's the Bernoulli's effect in the terms of airflow, where there's pressure differentials, and you could see that this pressure differential caused the force, and the force caused the plane to fly, and like wow, amazing. Um, the problem I had is once I left school, two things happened. One is that the real world of of people and medicine to some degree and maybe not so much medicine, but definitely people and supply chains and econometrics as is the common field for this doesn't have this straight like this happened relationship, right? It's not physics, it's not bounded by the literal laws of the reality of our universe, but they're human constructs. So now like, oh well, what equations can you describe to use to figure out cause and effect? They don't just exist. There's not like a thing that just exists. The second thing though, if we go into the social side, is once I got into industry, I lost that learning environment, right? For the early parts of my career, this is actually one particularly frustrating part of my own career is now you're in work and some companies, all companies are about making money, and some companies just want you to make money, and the people in it are not so interested in learning. This is not let's say sorry, what's the word I'm trying to use? I'm losing it. This is not like an attack on companies or like, oh, commercialism is bad or anything like that. But like at school, you're in a structure where the idea is to learn. You have professors to learn. You have people. You have a community. And I lost that. So it's taken a decade now to build it back up in the form of this book club, right? One way is I got more and more into statistics, and we'll talk about math and statistics and correlation. So I'm, as you know, and now I know Bayesian inference and all these sorts of things. But I never got quite back to the cause. I got really good at correlation and got really good at graphs. But as you and I will talk about in a second, as we're learning, that doesn't necessarily mean causal. And then I also just realized it's easier to learn with people. The reason I think I thought the book club would be fun is that I could read the book on my own. I literally had the book for a year and a half on my own, and it was just sitting there. And I figured, hey, if I start this book club and other people join in, then maybe I'll start learning. Now I've got all these people that show up every week, so if I don't start reading the material, I am embarrassed. So that's a good negative social influence that I should, hey, read this book and stay and keep my word, my social word that we're going to do this. But also, it's been great learning with all these folks here. The ones on the chat every week. Well, every couple of weeks they challenge me. Everyone is engaged, they're asking questions, and together we're learning more than if we just did it by ourselves. So I haven't mapped whether there's a causal effect, Demetri, on that, but certainly there's been a strong correlation between the book club and my progress in the book.
Right. That's very interesting to hear. I mean, I think I had a very similar experience. I did my undergrad in applied math, which is like very adjacent to physics, and so, it's like asking like, well, why does a plane fly or why do balls drop? It's like, well, it's just F equals ma, and there's nothing more for me to say about why things drop and stuff like that. But after starting my PhD, where I had moved from applied math and which was like mathematical physics to epidemiology, which is admittedly more of a social science than it is a science, in my opinion. Now you have to start accounting for things like endogeneity. Like I learned that word just a couple of days ago, and and these are the things that it's like, no, if you just it's not sufficient to say if you do this, then this will happen because of these endogenous. Oh God, I'm hoping that I'm using that word correctly.
It's
These
okay.
endogenous things, right?
Yeah.
So, the reason that I wanted to learn causal inference, I think, was to start to first of all, it's a big part of epidemiology, right? Etiology, knowing if smoking causes cancer, that's the biggest one, or whatever, is a really important thing. When I moved to industry, though, I saw that it was also very useful because in a lot of industrial settings, you run experiments, right? And oftentimes those come in the form of A/B tests. You just randomize people to two groups, and then it's like, well, the only thing different because there's no backdoor paths between the exposure and the outcome. Then you can make a causal inference. Some things aside. Um, what I found really interesting though, and what really motivated me to like actually buy the books and start reading them, is it's one thing to like just like say, oh, I'm gonna experiment, I'm just gonna randomize to two groups, but it's a completely different thing to like come up with hypotheses for those experiments to say, if we could change this thing by one unit, if we could make users more engaged, if we could decrease churn, if we could force something to happen, then what? And that's what really interested me, is like coming in with like, or developing quality hypotheses for experiments. So it's like causal inference to do causal inference. Does that make sense?
It does. Now, the question I'd have for you there, especially because you're such a well trained statistician, is couldn't you just why did it matter that there was more than a correlation, especially in business, and you really did want to get the causal effect? And also in these randomized control trials, wouldn't you essentially be getting the causal inference anyway because you're doing a randomized control trial? So um, in that sense, I would think you would already just know how to do it. You take a randomized group, you apply one change, and you end up with something else. Where did it stick in your head that actually this is not going to work? I need to go learn more about this field of causal inference.
Yeah, because that's a really good question. So you're right. When we do an A/B test, we can just get the causal effect because A/B tests and randomization is really nice property. Why do I
Yeah.
want to do the causal inference before?
Hmm.
That's the question?
Why? What? If randomized tests already get you your causal inference, then why even continue on with the rest of the causal inference methodology? And then that's
Right.
one, which is your path of learning. And then the other question I have is, especially in business, why do you think it matters more? If you have the correlation, then you sort of get the sense that when you do this thing, this other thing will happen. I'm curious in your line of work why you cared more about the causal effect more than just the correlation. Because if you have the money machine that'll just do money stuff, and you know the correlation, then you're good, right? What does it matter what the specific causal effect was about the thing you did? Does that make sense?
Well, that does make sense, and it's not. I don't think it's so much about estimating causal effects as a means or an end as an end,
Okay.
right? The fact of the matter is like running experiments takes time and resources, and so you want to prepare yourself in a way that sort of like sets you up for success. You don't want to just like it isn't as if scientists or product managers go around being like, oh, well, what if I change the color? You really want to sort of like have a really good found like theory almost of the product, and then
Okay.
you want to test that in the A/B test. And so to avoid that sort of floundering, that sort of just haphazardly experimenting on stuff, I want to come with it being like, listen, here's the model, here's my estimate. If we change this, here's what I think we would happen. Let's test that. So
That's
that's my approach.
That makes complete sense. So with the summary that I heard, and let me know if I got this correctly, is sure you could treat your organization just as a whole, as a random walk, right? And randomly try this and randomly try this. But what you're trying to do in your organization is take a more nuanced path where you're actually starting to learn, say, the organization and the business as a whole as a model, and take smart steps, and causal inference is a more informed way for you to make these hypotheses than just change the number of mailers, change this, and just sort of like randomly get to some path. Okay.
Yeah, if I were to put it in like a pithy comment, I want to develop a theory of the product rather than just testing stuff to test stuff.
Got it. That makes sense. Then the other question I have for you, and I hope you don't mind me dropping this piece of information, but you've been working at this organization, and I'll let you name it if you want, a short while here. And so you came to this understanding really fast, actually, and like kind of astounded how fast you went from taking the job to like now realizing you're going to use causal inference. And the question I have for you here is, did you know that before you started your organization, or are you just a really quick learner and you figured it out within the last couple of months that, hey, this is actually the field of study that I should look into?
I think that's a false dichotomy.
Okay, fair enough. You can break my false dichotomy then.
I tell you what. So the company I work for is called Zapier. Like
Okay.
it isn't a secret. It's on my LinkedIn.
Okay.
So but I did come in and I thought I had an idea of. I thought it was going to be much like I described it. You just sort of test stuff and be like, oh, well, we think it's here. But then I started to realize there's a lot more research that goes in that. UX UI is a thing, and that they have actually some very important insights into how the product can operate and how we can change it for the better. And so I started to think like, well, UX UI has these insights, product managers have these insights. What does data bring? Aside from the ability to like make cool dashboards and stuff. And I think that causal piece, that theoretical piece, really brings something useful. So I sort of knew that that was going to be an element. I didn't know that it was going to be in this particular way. And I should also shout out to Sean Taylor, who I'm trying to model myself after. I feel like this is inspired by him in some strange way, but I can't say exactly how.
Okay, well, there's a couple things that I can lean on. One is, another reason I wanted you on this podcast, or not this podcast, this first live stream, is I not sponsored by Zapier, but Zapier is a really cool company. So I'm saying that from my heart. There's a lot of cool folks working there. So I knew that I had some sense that something at Zapier triggered Demetri to start learning causal inference. And I wanted to know what that was. I actually, folks, didn't know what that was a priori. So I'm here learning this with you. The second part is, I hope Sean Taylor doesn't cringe when we're both talking about this, but Sean Taylor also is a model for me in the sense of like, he's done really cool things in industry. And I noticed he was doing something for a while, even when I really knew Bayesian stats really well. Actually, even before I knew Bayesian stats at all, when I was at SpaceX, somebody had brought up this profit model. And they're just like, oh, this forecasting model is really cool. And at the time I was in the middle of like the machine learning sort of, just like everybody else, was trying to fit all these random forests of time series and fit neural nets. And I had like no idea what the hell was going on in these models. But then this guy, Sean Taylor, and I forgot his co-author's name, but they released this package named Profit. And I was like, wait a second, this methodology works really well because I can see the components. Like this is much more useful for me. And then since then, as I've learned more and more in the field, Sean continues to produce really great work at all the organizations he worked for. And clearly he's given a number of good talks on causal inference. So for me, I was like, okay, this is something worth learning if Sean Taylor's doing it, who has this history of really great work in industry, I'll say. And that's the other important part. I noticed a lot of work is done, and this isn't a knock against causal inference or any sort of math, but a lot of it's done, let's say, in the context of papers, or done in the context of academia. But for me in particular, when I see folks apply it in the context of industry, because that's where I'm at, it becomes, I'm like, okay, there must be some relevance here. So if we take the field of causal inference, for instance, you see a lot of it in papers, right? There's like, did smoking cause lung cancer? maybe that one's not so much in a paper, but other papers where econometricians are trying to, over the span of like, let's say 10 years, say that this government policy caused this. And there's nothing wrong with that type of research. It's just, I don't have 10 years in industry. So for a while, it's like, maybe this is just a thing you need to wait 10 years and then see what happened. But when folks like yourself or Sean are using causal inference in practice, like, okay, this can be done in the time scale and within the attention span of businesses. I have to bluntly say businesses have a shorter attention span than academia. You have to turn out results in the span of weeks or quarters. So this leads to my next question for you is, are you applying this stuff at work? And you don't have to tell us what you're doing specifically, but is this something that you're using, say, quote unquote, in production? Or are you still in your causal inference career in the phase of you're learning this and you're seeing where things can be applied? You just told us why you want to learn causal inference in the context of industry, but where are you at in that journey?
Yeah, good question. So, like, admittedly, it's still, my understanding of causal inference is still nascent. I am by no means an expert, and I would not feel comfortable like quote productionalizing causal inference at Zapier quite yet. So at Zapier, it's experimentation is I won't get into it, but we're putting a lot of effort in order to scale experimentation at the organization. So we're productionalizing causal inference only insofar as we can do it through a randomized control trial or an A/B test. But beyond that, and who actually be a really good person to talk to is StatBlock, because he does causal inference on a completely different scale than I would. But to answer your question, like it's still very nascent. My understanding is still nascent, but I'm hoping to get there within 6 months to a year.
And that's not a shame at all. To be honest, my use at my organization, Google, and I should point out, neither of us are probably representing our companies in this casual chat, but
Right.
I'm not using causal inference like in production at Google either. I mean, they're literally causal inference experts on Google staff, as you can imagine. I am not one of them. I'm just learning it, but it's interesting. For me, what's interesting is in my own head is now I'm like looking at things much more suspiciously than I was in the past. I think going through these causal inference books, I'm realizing more and more. I'm like, oh, even if there's a pretty chart, I need to think about confounders. I need to. Well, the biggest thing is I need to construct a DAG in my head, right? I think like in my head, maybe I was implicitly constructing a DAG, like loosely, not really thinking about it, maybe subconsciously. But now after going through like the causal inference mixtape, for instance, now I'm like, oh, I really should write down a DAG because like this is going to form my thinking. And it's actually really important that I am clear to myself how I'm thinking about this problem and not loosely thinking about it. Because if I construct it one way or construct it another way, the interpretation of this chart could change substantially. So I think it's starting to like seep into my brain in this like loose way, but I've not gotten to the point where I've been doing like a synthetic control or something like that yet.
Yeah, like no difference in differences, no instrumental variables yet. Like I'm still in the randomization step, but you put up you raise a really great point. Like you always got to draw the DAG, and granted, I have no understanding about these other methodologies, but at least I know. I love a DAG. I know what a DAG means. I'm interested to hear maybe even from the chat, and I know you said that you maybe don't use causal inference in your like day to day, but like one of the things I've run up in is like when I'm talking to people who, even like statisticians who aren't causal inference experts, like I want to get them to draw a DAG, but I don't want to be like, draw the DAG. Do you know what I mean? So I'm really interested. Like one of the things I want to figure out is how to have those conversations with non-technical and technical people about drawing these assumptions in the DAG without being like, this is a DAG. And I still haven't found a good way to do that yet.
So some of this, admittedly, some of this comes before my causal inference background or my recent interest in causal inference. This is a good question because you're forcing me to think really hard.
Sorry.
No, it's okay. Even before I was
a habit of doing that.
It's okay. I actually like this, folks. You can tell that we didn't pre-plan this conversation, which is hopefully entertaining for you. This whole idea of a DAG was important to me even before I was formally learning statistics at SpaceX, because the whole point of my job at SpaceX and the companies prior and even the companies after, but we'll pick SpaceX because it's a great example, is I have to convince people that if we do a certain thing, like we're going to get the rocket out faster or cheaper or something like that. Like that was literally every conversation I had in operations and supply chain. It was if we pay this supplier to expedite this part, I mean, will we get it faster? It's not guaranteed we'll get it faster, right? Because if we pay them and they're delayed, due to like a physical reason, like they have not made the part yet, like they're not going to get it out faster. Versus if they have the part and they're just waiting on it, then paying them could get it out faster. There were other things. I think it's no surprise Elon changes things all the time, right? He's always forcing change, and not a bad thing, but like that forces DAG sort of questions, and that other questions were like, if we bought this new machine, or if we this is a good one, if we change the way we process this part, are we going to blow up the rocket by accident? Like those are literal questions we had to answer. And so there was a lot of times in stakeholder meetings. I guess maybe this sort of is a DAG now that I'm thinking about this, but you draw these diagrams. Wow, I'm forgetting the name. I'm so far out of mechanical engineering practice. I'm like forgetting the names. But there's these diagrams, these sort of cause and effect diagrams that's used in what's called failure analysis. There's a big field called failure analysis where when things fail in catastrophic ways, actual PhD training, my advisor in undergrad, they create these FMEA diagrams of like, this action could have caused this outcome or could have caused this outcome. And if that happens, then this happens. And if that happens, this happens. So a really famous example of this is when there's this vehicle called Amos 9 that blew up. And we had to figure out what all the potential causes were for this vehicle to blow up. And so to then answer your question more directly, how do I do this, Demetri, in practice is I sit down with stakeholders. They could be business folks that are interested in the money and finance. They could be people that are in the product, and we go, what is the thing we're trying to change? Are we trying to change the user experience? Are we trying to change the amount of money? Like, what is the goal? Or in statisticians, we would say, what is the metric we're trying to affect? But in this case, in business settings, parlance, I'd be like, what is the end effect? What is the outcome we want from our users or finance? And then we say, well, what are all the levers we know that'll help us get there? Or if we know the lever, like what is the lever we're looking at? So if it was user experience, to be like, okay, is it the amount of time they spend on the website? Is it the price of the product? Is it this? Which ones do we think have the greatest magnitude, and which are the ones that we think we can change? So one of these is a statistical question. One of these is a business question. And then brainstorm, like, what if we change something, what could happen? So in the Bayesian context, now that I'm pretty good with the Bayesian stuff, is like, this is a form of like prior elicitation. So this is what I did. SpaceX would be like, well, what do you think the effect is before we do it? Is it small? Is it big? If I had to draw like a curve or maybe a couple points, what do you think it is? And it ends up being this like back and forth sort of brainstorming. So sorry if I'm rambling here a little bit. I'm making myself off my head. But it's like, what do we want to do? And like, why are we doing it? So everybody's motivated on a team. What are the possible things we could do to get what we want? And then what are our set of beliefs about what is gonna happen? I think that loosely draws a DAG, and but I will say that where the causal inference stuff now is changing this pattern is I used to just draw them like linear, like these three things are independent. Let's draw these things independently. But now I'm like, oh, these three things might actually be a DAG. Like we do this, it affects this thing, and then that thing happens. So now I'm like, have the backdoor paths, right, and the collider effects and all that. I didn't have those pieces before. It used to just be all just straight shots. That's how I've been doing this stuff. In SpaceX and at Google, when I talk to stakeholders now, it's about the same way. There's a Google Docs and there's long comment threads where I'm like, well, here's what we see as the result. What are possible factors that I should look into, so we can start to estimate why did this, at least what was correlated with this thing. How's it been for you now that you're in industry and you've been working with folks now? What is your
I mean, about drawing DAGs and stuff. Well, I mean, it's kind of it's easier to do with non-technical people, I find, because I feel like you sort of just like people just like kind of get it. They're just like, I see that they don't understand like the flow of information and backdoor criteria and stuff like that, but they say, okay, you know, X is somehow affecting Y, and then Y is affecting Z, and so they kind of get that, and it's a nice little picture, and I find like people love pictures. Sometimes sometimes when I'm talking with technical people though, and this was the case for me, like when people would try to get me to draw DAGs as a statistician, something wouldn't click. I guess you know what I mean. It's just
Yeah.
like I know you're trying to get me to work in a framework, but it's not the same framework I'm trying to work in, and so it's just this sort of like I think I just started and like talking past people when I tried to do that, and people tried to do it with me. So I'm still trying to work on how best to do that with technical people.
You know, it's actually interesting you say that now that you bring that up. I have that same sort of feel, is that when I work with people that don't do this stuff, it's the conversations are very fluid. But when I work with some of the technical folks, and we're technical folks ourselves, so we're criticizing ourselves maybe, but they know what I'm trying to do, and suddenly it becomes like a PhD thesis type of thing where we're like really talking about, like, it becomes like not a fluid conversation, but like a math formula. So I actually am trying to figure that out as well. I've had numerous back and forth with one of my coworkers about, is this a backdoor path? Is this not a backdoor path? I will say one thing that a level I haven't gotten to, and I don't know if you've seen these, but while we bring this back to Sean, at Lyft, they've publicly published these big DAGs about writer models and things like that. Sean's got a couple in his talks. Lyft has a couple in its blogs. I am actually, frankly, very amazed that there is enough coherence at Lyft between the technical folks to come together on that DAG, because I haven't figured out how to get to that level where everybody's confident enough to put this on the internet. Like, we're still arguing about it in our team, and here Lyft is like they reached this level of teamwork and understanding with each other and the technical folks where they can like publish this. So I'm right there with you. I haven't cracked that nut yet.
Yeah, I totally agree. And another reason why I want to model myself after Sean, I feel like he has a big part to play in that, although not the only part for sure.
Yeah. So aside from the business side, I'm gonna bring this maybe back to the learnings. What is where are you at in either the effect or the mixtape? Like, what chapter are you on? To give you some context, we're on the Regression Discontinuity chapter in the Causal Inference Book Club in Scott Cunningham's book. So next week, if you guys folks are listening on the live stream on Sunday at our usual time, we'll do the regular sort of thing we do on regression discontinuity. But for you, Demetri, where are you at in these two books? Like, what's the last topic that you have picked up?
Oh God, I gotta remember. So I was reading The Effect for a while, and it's a good book. I think it's really accessible for like people who are sort of scared away by equations.
Yeah.
I think I got to maybe chapter 9 in that book. I can't remember, but I sort of kind of got like, it wasn't great for me because I like equations. Go figure. It kind of helps me think a little more clearly and saves me some economy of thought. So then I switched to the mixtape, and I've read chapters, I reread chapters, I've gone back and started again because I'm just like, something like I've clearly missed something. So I think I'm in chapter 4 of Scott's book, which I think is just after the DAG one. I think we're starting to talk about the average treatment effect.
Yes.
The average treatment for the treated group, the average treatment for the untreated. And like, I'm really trying to like square away in my head, like what these things are in theory and what they are in practice.
Yeah.
And so that's where I am. I have started and stopped at least a dozen times.
Okay, so this is great. Everyone on the live stream has read that chapter. We had read it 2 chapters back. Good to know where you're at. That was the diff and diff chapter, and yeah, that was the first brain bender for me. Quite as well. I don't want to pick on your on one area too long and make you feel too embarrassed. But I'm curious, what's holding you up in the different diffs? As you explain it, maybe other folks will get a revisit of the topic as well. Like, what's the part that's not clicking?
The part that, so it's not difference in difference. I'm in I think it's chapter 4 where you literally start to talk about the kinds of the treatment effects.
Okay.
So the thing that sort of like, now I have to think like, why was I confused, which is a good exercise that I should do, not on YouTube. But
yeah.
it was easy to say, like, I think initially when I read that book, I read the ATE as like the difference between people who were untreated and people who were treated.
Yeah.
And like that is an estimate, but it is not the average treatment effect, right? There's I think the problem for me was the idea of the counterfactual outcomes.
Yeah.
So yeah, go ahead.
So I'm gonna say, and it's not a knock on the Causal Inference Mixtape book as well, but that section of the book confused me quite a bit as well. You saw me looking around because I'm trying to find. Oh, I have it right here. I'm gonna grab it real quick.
Yeah, go for it.
This will lead into my next question for you, but I actually struggled with that portion in the Causal Inference Mixtape book as well. The folks in the live stream had seen that this book actually it clicked for me in this book. There were good examples that explain the difference between average treatment effect and average effect on treated units, and then the two other sources of bias. And reading it here helped me quite a bit, just to get a different perspective from different authors. They use different terminologies and different examples, and then it clicked. But there was like a good 4 or 5 days. I was like, "What the hell are these things? What are these not?" Scott doesn't use this word, but like not parallel path assumption is one of those biases that the treated units and the untreated units will have the same. When they get a treatment, they'll have the same effect. Like it'll be the same unit, and that is one source of bias. There's obviously the two other ones as well, or where there's the one other bias, and then there's the actual thing that you're trying to get. So reading multiple books has helped me a bunch, and to save you from having to this painful part of the conversation, the second question I had for you is, I haven't read The Effect. I was thinking about buying it. So the folks again in this book club are reading Causal Inference Mixtape. What is it about The Effect that you have liked, and what are the differences in this impromptu book review between Causal Inference Mixtape and The Effect? Like, what? No equations is one thing you mentioned. We went through that. Is the writing style different? Like, are the examples different? Like, what is just your hot take on that particular text?
Oh god, I wish I had it around me somewhere. I'm moving and I have no idea where anything is right now. But so at least I was hoping to flip through it and at least remind myself. I think one of the differences was the mathematics, and we'll start there. I think Nick starts out and says like there's minimal equations and that's for a very specific purpose, and I forget what that purpose is, but I think he meets it. Like I think it's a very approachable book, and he can, like, the way he describes things like the backdoor criterion and all of these other causal theoretical quantities, he does it very well in words. It's also like just kind of really super accessible. I don't think it doesn't really assume a lot of familiarity with statistics, like a little bit with statistics, but he like actually is very patient in the way he describes things that I think some of us may take for granted. And the effect of the effect is that it's actually quite a thick book. It's like much bigger and thicker than Mixtape, and I think that's because there's that patience there. So I think those are probably the two main axes.
Okay.
It's a good book. I don't think it's for me, but I would definitely recommend people at least read a couple of chapters to see if that's the style in which they learn.
Well, you've convinced me. I'm gonna buy that book now. I was curious about it as well, but now, yeah. Okay. Well, you definitely had a causal effect on me. Go ahead.
The counterfactual one, which I
yeah.
For people listening, I think that the book is freely available on Nick's site, so you can read a couple of chapters, and if you feel like you can throw him a couple of bucks, then buy the book. And it's a beautiful book. It looks great on my shelf.
Yeah, I think so. And there's the adage like don't judge a book by its cover.
Right.
Well, The Effect, I'm definitely both Causal Inference Mixtape and The Effect. The reason I'm biased to both of those books is the authors. They made a bespoke cover on both of them, and they spent a lot of time on it. And if they spent that much, as someone who's an author, if they spent that much time on the cover, I'm fairly confident they spent a lot of time in the book itself. With Scott's book, we know he did. He put a lot of cool quotes in there. He's got a good style, so I'm making that same sort of assumption. All right, I'm gonna buy the effect. I think that'll be good. To round this out with a couple more questions, then,
Sure.
what is the most what topic are you the most excited to learn about in causal inference? I'll start with one. I keep hearing this thing about synthetic controls more and more. How synthetic controls. I don't know a lot about it. It's gonna be a terrible explanation, but it seems to be like this new methodology that, as the name implies, you can start applying controls where there wasn't one in past. When we talked about academia versus industry, I don't have the ability to do random experimentation. I mean, I couldn't do random experimentation at SpaceX at all. You can't randomly experiment on rockets. And I deal with a lot of observational data. So a lot of times, right? Like for you and I in business, there's data sets being generated all the time, and it would be dumb for us, to be honest, to say like, well, we need to redo a thing, but now we need to redo it in an experimentation framework when there already is like years worth of information stored up in our databases and things like that. So in my head, I think synthetic control is going to be this thing that'll help me maybe take observational data that wasn't generated in the context of an experiment and gain some causal inference ideas from it. But that's what I'm excited about. What topic or which like methodology seems really fascinating to you that you can't wait to get to?
So first, I'll say that synthetic control is super cool, and there is a talk on YouTube how like Uber used synthetic control in one of their experiments. I'll link you to it when I get a chance.
Please do.
The thing that I'm sort of most interested in is regression discontinuity, and for a really good reason. At Zapier, like it's a lot of people just want to be like, let's just change the thing and then we'll see what happens. And that's like a typical thing when you like roll out a new feature. You roll it out to 10% of your base and then 20%, and it's like a slow rollout, right? And people like that. And so like rather than try to fight people against it, be like, no, you have to randomize. I'm really interested to see if we can use like regression discontinuity and sort of meet them where they already are, and do like a valid causal inference of the effect of whatever the change was, without having to sort of like, no, let's do an experiment. So, you know what I mean? Like,
yeah,
I think if you do that, you come off as like a better, like a data scientist is like more amenable to work with. And so it like satisfies two things, right? It makes me look good, and I get to do cool causal inference stuff.
Yeah, I agree with that. I think just to underscore that, actually, there was a good year in my career. It was when I was at Sweetgreen, where I was like getting really into stats, and I was like, we should make everything an experiment. And I was pulling up this Harvard Business article that said like great companies experiment, and people were not nearly as excited about experimentation as I was. That was when you talk about ways to talk to stakeholders. That was not a way to talk to stakeholders, because they didn't care about experiments; they cared about outcomes. And me coming in being, let's do experiments, was like very nerdy. And it didn't fit that culture very well. So I think good thing you're not making the same mistake that I am. Much smarter. The other thing is, for the folks that live stream, regression discontinuity is the current chapter that we're reading. So you heard it from Demetri. I didn't pay him to say that. Regression discontinuity. It'll be 2 chapters ahead for you, and the current chapter for us is the thing we'll talk about next week. So I'm really excited to pull that one together. Yeah. I'm going to read through the chat here, Demetri. There's a couple people that have left questions or comments. Let's see if we want to obviously include them in the discussion. Alexandra says, randomization does not protect you from accidental confounding. Theoretically, those two groups will tend to be similar. I think you're right, Alexandra. We have to pay attention to randomization. Plus 1,000 to developing and understanding. Oh, Ambika says plus 1,000 to developing an understanding of the data generating process versus randomly testing stuff for long-term success. How do you talk to stakeholders? We had a fairly extensive chat on that, but anything else in the last 20 minutes that you want to add about talking to stakeholders?
I think in a phrase, I think you got to meet them where they already are, rather than force them to come over to where you are.
Perfect. Annie said, if you can share, what kind of causal inference projects have you applied at Zapier? Thanks, Annie. We had that same, I think we also covered that in a discussion that you and I are both working on it. We're not at that level where we're like, we've got a strong one in mind and we have great results, but we're working our way up to that. Fair summary?
Yep.
And then Brian says, for me, Causal Inference Mixtape doesn't have enough implementation or discussion of that code. I've been supplementing with, I'm going to butcher this author's name, Matthias Fracture's free book, Causal Inference for the Brave and True. Actually, I really appreciate that. Demetri, have you seen this book, Causal Inference for the Brave and True? Okay,
No.
we will. I guess we're gonna put these all in the show notes or add them. I don't know. I'm not very good at YouTube. These YouTubers say these things, and I've seen enough YouTube videos where I'm just gonna say the same stuff. So maybe this is making me a YouTuber, but we will add it to the comments so everybody can see that. I actually think more importantly, we'll link these. I'll link these in the discourse thread. For those watching this for the first time, we have a discourse community, which I actually really like. This is a total tangent. I hope you don't mind me jumping on a tangent. I feel like the internet is very noisy and stressful these days. And like Twitter's kind of okay because like I get tweets from like Demetri, but then I get all these ads and like other crazy stuff that like drives my brain wild. And then YouTube is good, but YouTube is very distracting because like right next to a video about how to learn something is like Mr. Beast video. And I just can't not click the other video. So our discourse community is like this safe spot. Like when I go to it, there will be people talking about either if they're in the intuitive Bayes course, talking about Bayesian stats, or in the causal inference book, talking about causal inference. So that was a whole long path to say I'm going to post them in our discourse, which is a calm, safe haven on the internet for us to talk about statistics away from all the other crazy things that are happening. And to talk about causal inference for the brave or true. To give you my thoughts on this, Demetri, I don't know how much code is in the effect. I haven't read that book yet, but now I'm going to purchase it and I'll see. Causal Inference Mixtape, as you know, has a lot of code. It has stats, it has stata in R, and then there's Python translations. But not a knock on the book, but the code is like dropped in there. It's explained well in most situations, but it's not as explained well as I'm going to talk about myself now. But as in my book, for instance, I tend to like to explain the code a little bit more. But I didn't write a book on causal inference. This fellow wrote a book called Causal Inference for the Brave and True, and it's all in Jupyter notebooks. So I've actually been using that book as well because there'll be some explanation about concept in Causal Inference Mixtape. But if I want to see like the nitty gritty code all the way through and through, that book has been quite nice. It's free on the internet. It's a Jupyter notebook book, so I'll send that your way. Just another book maybe to add to the collection. I'd say when you come across a topic and you're like, how can I implement this in code? And I really want to see an implementation in code. This fellow did a really good job writing down the code and then explaining what all the code is doing. So another one to throw in the mix.
Sweet.
While we were talking, another question came in. Have you guys looked into more traditional non-DAG approaches to causal inference, mainly from the potential outcomes framework and most of the work from economists? I'm going to throw this one to you first.
Dude, I just learned what endogeneity means. No, I have not. This is my first foray, but it won't be my last. Like, obviously, learning anything, like, I think you just have to, like, you do a breadth of search, and then when you find something that clicks, you do depth, right? So.
Yeah, I think I'm in the same way too. I think the only comment I can make on this is there seems to be, and this isn't an indictment against the community. It's informing the way I'm learning. But there seems to be a lot of, I'll say, quote unquote, drama between the do calculus approach and then the not one and the DAG. I'm not advocating one or the other. I'm just noticing that between the people who are literal experts in this field, who've studied this more than I've literally been alive, they have differences in approaches. So I'm really curious to learn what it is that's driving this. Again, not saying someone's right or wrong, but when I see experts disagreeing and people thinking about it, like there's something there. The common one is the Bayes versus frequentious one. I didn't understand that for a long time. Now I do, and now I feel like I'm not saying someone's right or wrong, but it's like you can see the because you can see the differences in approaches, you understand both approaches better. That's sort of the thing that I'm trying to do here. Like I don't know the potential outcomes framework, and maybe after we learn this stuff, I don't know, you and I can learn the potential outcomes framework, and then we'll know each better because we know what each does differently or where they start and where they diverge. So Cool.
Sure. Yeah, we'll do it all again.
Yeah. Well, yeah. Okay. This is a good one to say. Maybe we'll have a second chat in a year where we'll be like, oh, we're causal inference experts. We know the potential outcomes framework. We know the effect. We know the effect. We know the mixtape book. We've read it all. We're just gonna tell you what we know. I think that's I don't know. It's a pretty good segue to the closer here. Do you have anything else you want to add? Any topics I didn't bring up?
Nope, not this time. I think we did a pretty good job covering some good stuff.
Yeah, I think so as well. Audience, I'm going to give you these live streams, as you know, are usually lagged about 10 seconds from. So the question I have is, do you have any questions for Demetri or for myself? Anything you liked, anything you want to drop off? Demetri, we have to do this awkward thing where we pause for about 10 seconds because the speed of what we're talking is like a delay before it gets to YouTube. So I do this thing where I count 1, 2, 3. All right, so we'll do a couple of quick questions here, and then we'll last ones and we'll close it. We got a question here. Do you find it helpful to jump back and forth between the books on the same topic? So, have you? Yeah.
Yes. Sometimes. Oh God, maybe. Okay. The answer is yes. Sometimes having a different explanation on the same thing at the same time can help you get through things.
Okay, for rapid fire too, that's been helpful for me. The reason is I don't know, maybe this is my brain, but once I've walked the path of narration in a book once, the first time is novel and interesting. The second time actually feels like eating my vegetables. I'm just like now sort of bored with the walk, but like picking at the details. And like the third time, I have a really hard time forcing myself to learn something new. So when a different author narrates it and it's a different path of discovery, then somehow something clicks that I missed from the earlier path of narration. So for me, when I read, actually in general, and it's something that I love about our new learning environment, is sometimes I read a book, I then watch a YouTube video on it, and then I watch somebody's talk, and somehow between the three, even if they're saying the exact same thing, the thing ends up clicking. When I was learning Bayesian stats, this was actually pretty big for me. I read a book, I would watch Chris Von Zerk's talk, and then somehow it clicked. Another rapid fire question. How well do you feel you have to understand causal inference before you feel confident enough to use it in a work project? This is a pretty...
Oh man, that's a good one. Crap. Me personally, I feel like I gotta learn, I gotta know it inside of it but I feel like that's just a personal thing. I don't think I can make a normative claim like you have to be this proficient in order to do it.
For me, this is something I've learned over the years. I used to think everything I did had to be like, it was like life or death. It wasn't like literal life or death, but I was like, oh, I could lose my job or not lose my job if I screwed this up. And over the years, I've learned there's actually like levels to projects. So I would feel pretty confident using like a different diff methods on something small at work, like maybe trivial. I've never used it. I'm not an expert on it, but if it was a small thing that let's say was, did my training have an effect on people's happiness at their job? Like, people's happiness is important, but like, I'm not going to take down Google's not going to crash if I just ask my coworkers if they like my internal SQL training or not. So I think I might use like causal inference on some small thing like that. I do not feel good enough to use causal inference to make like anything more than like a $5,000 decision at Google right now. There are people like Sean Taylor who make multi-million dollars decisions using causal inference. I'm not that person yet. So Brian, my answer to you is I'll use it on small things, maybe internal things, maybe things that have low stakes to get some practice with the framework. I definitely don't feel confident enough to make critical, non-reversible business decisions at this moment. With that, I don't see any other questions on the chat. What I can say to you folks, well, Demetri, do you have anything else that you'd like to discuss?
Nothing I'd like to discuss in the last 5 minutes. I will say that it's been super fun, and thanks for inviting me to test out this new format. And it's also really fun to like not be the person who's asking for, or like who's being asked like for all the recommend. It's fun to be the other person on the other side of that and be like, I don't know what I'm doing. That's been fun.
Yeah, actually, so admittedly, there were a lot of potential outcomes for how this chat could have gone. The first one was the technology failed and we're just awkwardly fumbling. Thankfully, that didn't happen. I think the other one is this interview could have been really dry and boring. That didn't happen. I didn't accidentally insult you, which was another outcome I was worried about. But oh no, this actually, like, for first one, we honestly were just winging it. This has been fantastic. This has been a lot of fun to start the morning with on my side. What I want to close with then is, you folks know where to find me. We have the discourse community, and you can post questions and comments, and obviously you have this YouTube channel where you can do things as well. But I also say Demetri has quite a strong Twitter following. He's so I'm sure he wouldn't mind if you add him, and you might. I'm just saying that, so maybe I've offended you now, but you can find Demetri on Twitter. He's quite active there. If you've got questions for him, super friendly fellow. He's definitely worth following. I'll say good mix between statistics content. His dog named Koshi is on there as well. Makes an appearance, so worth following
From time
that
to time.
as well. Yes.
My Twitter tag is @PHDemetri.
And I will, yes, I will drop it in this chat and in the comments, do all the social media crap, and then also I'll add it to the discourse as well. But with that,
Very cool.
I know you're busy. I know you need to move, so thank you for taking the time out. I really appreciate it.
Not a problem. Thanks for having me.
All right. See ya.
All right. Cheers.